All right, so it's time to address missing data now, and I'm going to do this in two parts. Initially, I had these functions divided up based on the type of missing data, but I don't think that's as useful. First of all, let me review these types of missing data. So we have data that are missing not at random. This is the case where there's a value that is theoretically accurate that we can plug in. Oftentimes, this is a 0. So for example, let's say we have a data set about orders and or maybe products, and we have inventory on hand, and there's a column that represents the amount of inventory on hand. And if it's null or missing, that essentially means that they have 0 missing. Well, that's easy. We can replace all null values with a 0. Missing not at random is our favorite type of missing data because it's easy to fix, and it's with a high level of accuracy. These are really the two that we have problems with: missing completely at random and missing at random. Missing at random means that there's bias involved in why it's missing, or there's a difference between the rows that have missing data and those that don't. There's differences in the population, maybe the means and the standard deviations of each of those features in those that are missing versus those that aren't. When that happens, we have to drop columns, drop rows, or kind of the old school method was to replace with a mean, median, or mode. But even then, I would only use that if there's maybe one missing value in the entire row or a record. Missing completely at random is when there is no bias involved, and the rows that have missing values have the same population means across all the other values they do have as those that aren't missing any data at all. In those cases, we can impute a value or predict a value. So I want to divide these cases up into two functions that can aid or support the process. Missing not at random, there's not really a function needed. You can write one line of code you can use fill_na, df.fill_na with a particular value. That'll replace all the rows that are, in fact, let me just put this right here as a reminder: replace with theoretical value, e.g. df.fill_na. All right. Impute a value is where we're going to use the sklearn iterative imputer. That's a linear regression based prediction. They also have another type that when I get to that video, I'll show you how to use a clustering. Well, I won't even get into it now. I want to address this missing at random and start with a function that will automatically drop rows and columns if that's what you want. In fact, that's usually my preferred method rather than even try to replace with a mean, median, or mode. That just adds so much bias, and I don't think it's particularly helpful. But you might think, well, why do we need a function to drop rows or columns? Here's the reason. Here's the problem. So here's a sample table. I've got 4 columns, 5 rows. All right, if we use df.dropNA on this, by default, axis equals rows instead of columns. That's the forgot my closing quote, the default value. So I don't necessarily have to plug that in. Here's the problem if I just run df.dropNA on this. So dropNA says drop any row that has any value in the row missing. Based on this data set, it's going to drop the entire table because D doesn't have any values at all. It would make a lot more sense to drop the column D first and then call dropNA. And then that would drop both row 2 and 3, and it would keep rows 1, 4, and 5. Now, if the data were like this, let's say this is missing, I have a 1, 0, missing. All right, now I still have this issue where if I were to run dropNA, every row has at least one value missing. It's going to drop all of them. So I need to still drop this column that has most of the data missing first. Now, the function that I put together is not perfect. There are better ways to do this. In fact, I'd love if one of you came up with a better function and were willing to post it and share it or something, but I'll show you a quick and dirty way to start. Now, what I've got here is a record of the total number of values that are not missing throughout the table. If we go through it and add in the total amount of missing data to each of these, I've got 0, 1, 1, 3. Conceptually, what I want to do is check and see how many rows that I'll have left if I were to drop a column versus, and I'm going to go through each column one at a time and say, if I drop this column, what do I have left versus dropping every row of that column that is missing. And if I drop the column here, that's going to leave me with, here's my total count. So drop D, that's going to give me the equivalent of count A, this right here, 13. Whereas if I were to drop NA D, that would give me these remaining values, but drop those rows. So this would equal, count A, however, I've still got this issue where C and D have missing values. But if I just look at dropping all of D versus dropping just the rows that are missing from D, it clearly makes a lot more sense. This is the number of values I have remaining. It makes a lot more sense to just drop the entire column D. So I just want to put together a quick function that will go through each column one at a time and just test how many values will be left in the data frame if I were to drop the column versus drop NA of the rows for that column. All right, so let's go and do that now. Back here. Oh, I got to reconnect. Do that real quick. Let's go ahead and pull in our data set from the last video here. I'm just going to grab each of those and mount Google Drive again. Let's add in some extra code cells. All right. So let's go ahead and make a function. Let's have this, let's call this missing drop. So this is a function that just handles dropping rows versus columns. So I'm going to need a few things. The whole data frame. I also want to know the name of the label, because if the label is missing, no matter what, I've got to drop those rows. It makes no sense to impute or predict those values, because that's what we'd want to impute or predict anyway. And so I have to have those values if I'm going to come up with a good predictive model. I do not want to substitute with mean, median, or mode. I'm simply going to drop them if it's the label. So that's why I've got that in here. I'm going to make a features list. So rather than pass in one feature at a time, I'm going to pass in all of them at once and have my usual messages equals true. And I'm also going to include another one, and I'll show you where I'll use it later. Low threshold equal to. That's a default value that we're going to use to decide how many values can be missing in a row without dropping it. So basically I'm saying if it's missing 2 or more values, we're going to drop the whole row, no matter what. So this is a function we'd want to run after running basic data wrangling. Well, actually, technically, we can set this to handle that part too. So let's start by importing pandas as usual. I think that's the only thing we're going to need for this. And I want to start by generating a total number of cells in the data frame that gets passed in that are not missing. So start count is going to equal df.count. And let me just show you what this returns so you understand why I'm doing what I'm doing here. Import pandas as PD. Let's call missing drop on a copy of df insurance. We have to, I keep forgetting, we got to make sure we do this on a copy. Otherwise, the way Python works, it will actually save this over everything we do here. It'll save over the top of df insurance, even though we haven't set df insurance equals missing drop. So make sure we run this on a copy as we're practicing right now. Okay, I think that's good for now. Let's just run missing head. Oh, I haven't got a return here at all. What I meant to do is print. All I want this thing to do is print start count. And I'm not going to run .head because we're not returning anything yet. All right. So it's got 1338 values in every column. That's what df.count returns. I want the total number of values that aren't missing. So let's make sure we add to this .sum. Okay, total number of values in that data frame. Since we've got no missing data, let's switch to another data frame that does have missing data, like the Airbnb. That's a good one to practice this function with. All right, so that one's got a total of 295,000 cells that are filled in. The question is, how many total are there? So I'm going to print start count, and I'll just say out of df.shape 0 times df.shape 1. Okay, so there's a total of 320,400 cells in that data frame. And after counting up the number that are missing, we've got this 295, 375 out of that many. So there's plenty of missing data across several columns. All right, I'm going to comment that out for now. We've got our sum. Let's start by dropping the obvious stuff. So df.dropNA. Let's use this first of all on, I'm going to start with columns. So axis equals 0, or you can say columns. Either one is fine. It's just get quicker over time if you remember columns are 0. Or sorry, I said it backwards. Rows are 0, columns are 1. So I'm going to start by dropping any row that has more than the row threshold missing. So the reason why I've got 2, this is fairly conservative. If it has 2 values missing, then it's going to be tougher to impute or predict the remaining, those 2 values based on all the others. Let's say we only have 4 columns total. That means we're using 2 columns to predict each of the 2 missing values when we create our imputation function later on. That's not super reliable. Yeah, it gets more reliable if you have more columns. Let's say we have 20 columns, then I'm using 18 that don't have missing data to predict the other 2. So that's tough. We could turn this into a percent and then round it. And the way the dropNA works is we can have a threshold, but this has got to be equal to an integer. The way this function works, it's got to be a number of columns missing. So why don't we change, I kind of like that idea. What if we say row threshold equals, and we drop anything missing more than 10% of the data. So 0.1, that's our default. What that means is we're going to have to multiply this 0.1 times the number of columns and round that to the nearest integer. And that's otherwise, because if we put anything with a decimal in here, it won't work. So what I'm going to recommend then is that we say, let's multiply or round row threshold by df.shape 0. That's the number, 1. That's the number of columns. So 0.1 times, I'm going to print out how many columns this thing has just because I don't remember. I'm going to print that. And let's just add to it df.shape 1 columns, and that'll remind us so we can double check our work here. So df shape 1, and then I've got to round this thing to 0 decimals. I think that might be the default if I just leave that off. Let's see if that works. All right, so when we drop NA, let's make sure we also do this in place equals true. Let's give that a shot. Okay, so there's 16 columns total. Multiply that by 0.1. That means that'll round up to 2. That means 2 columns can be missing. 2 columns can be missing for any row in order to still keep it. So we've got to have at least 90% of the data. Do we like that row threshold to keep? Yeah, we'll leave it at 0.1. All right. So let's print out what we had in df before and after to see if this works. Print df.shape here. And then let's print it after this. Okay, so this got rid of technically 0 rows. We're missing 2 or more values. Let's double check what this is right here and see if it worked out the way that we thought. So I'm going to print here, going to drop any row with more than, whoops, I accidentally hit Control-C. Let me copy this one more time. More than that missing values. All right, let's see if that works. So that did work. This says that there weren't any that had more than 2 missing values. That doesn't seem right to me. Airbnb, I thought we had a lot more records than that. There we go. No, that's right. But it apparently didn't find anything with more than 2 missing values. Well, let's try to hard code this. First of all, let's change this to a variable. Thresh equals that. So I can put thresh right there and thresh right here. But let me hard code in here 1 missing value. Maybe that function's not working the way I think it is. So df.dropNA more than, that didn't work either. Let's try 3. No, I thought that data set, let's print it out here. I thought we had more than that many missing values across all of them. Okay, so here's what it looks like. Neighborhood group is missing for everything. Maybe nothing else is missing and I was wrong. Let's double check. Let's say isNA.sum. So neighborhood group's missing for everything. Then we've got these other missing values here. So let's double check the documentation on that. Okay, sure enough, I had it backwards. This is why we always check documentation. So I thought threshold was the number of missing values, but it's the number of non-NA values. So let's see if we can do this a different way. What we want then is basically to put in the number, the threshold we were thinking of, the number missing, of the total number of columns minus the threshold. So in other words, this is going to, there has to be 14 or 13 or more. No, let me think. See if we have 16 columns. I think we want 16, the number of columns minus this threshold is what needs to go right here. So for example, if I plug in 14, that means anything missing more than 2 should be dropped. Let's see if that works. There we go. So see how that dropped a bunch of rows. In fact, I'm going to assume those are the same 2404. That gets us down to 1760. Yeah. So that's working exactly how we thought then. This is saying anything that has less than 14 values that exist in the row is going to be dropped. So we're going to set the threshold equal to the total number of columns, which is df.shape 1 minus that threshold. Or we could just simply reverse this and say there has to be 0.90% existing, and then we could just say round that. That'll give us 14. That'll be the same thing. I like that better. So let's say that the row threshold is going to represent the amount of data that must exist in order to keep it. So we want 90% of the columns or more. All right, so let's take out this extra stuff we just used to debug that function. I know that took time for me to go through that, but I like keeping this in the video for some of our newbies to learn how to go through and do some debugging and printing things out. All right, so I'm going to get rid of this. We've got the start count, the threshold. There we go. So this is going to be drop all rows that have less data than row threshold requires. Then the proportion that row threshold requires. Okay, next, let's drop columns that are missing everything. I guess technically we could have done that first. In fact, we probably should. I'm going to first drop columns that are missing. Same thing we did back in basic data wrangling. Let's make a call threshold. And the question is, what should this be defaulted to? That's a tough one. I'm going to start with 0.5. and say if the column's missing more than half the data, we're going to drop it. So df.dropNA. Now we could do this a few different ways. I'm going to, well, we'll do it this way. Axis equals 1. Thresh would have to be, I guess I'm going to have to calculate this one as well. Well, you know, no reason I can't put it back in here now. I'm getting lazy. I'm going to put that one right there. Keep it all in one line. Row threshold. Thresh equals round call threshold times, this time we're going to multiply it by the number of rows as a percent, and it'll round to 0 decimal places. There we go. So any column missing more than half of it's going to go, which is neighborhood group. So we should see that gone as well. Let's go ahead and start returning this now. Return df. So I'm going to call that and run missing drop dot isNA.sum. Oh, let me run the function first. All right. So we looks like we got rid of not those columns. We just got rid of the rows missing those columns. And we still have 144 values missing here, 24 in name, and some of these it could miss both of those and still be kept according to this 0.9 threshold. If we wanted to get rid of some more of those rows, we could change that to 0.95 up there, or do this here as we copy it. .95. That one should have gotten us, oh, that means that the 24 missing here are different rows than the 144 missing there. Otherwise it would have gotten rid of those too. If we take it too high, it'll get rid of everything. There we go. But I just want to demonstrate how that works, and we'll leave it that way. All right, let's keep going. So now that we got the low-hanging fruit, then let's handle the label. So if label is not equal to nothing, that means they passed in a label. So we should probably go ahead and do that as well. In this case, the data set, let's say it's average review. Well, nothing from average review is missing. Let's test it by using name as the label. So if there's a label, then we want to go ahead and get rid of anything from that column that's missing. So all rows. So the way we'll do that here is we'll set axis equal to 0 for the rows, and then we'll say how equals all. I guess we don't even need how equals all. We're just going to say subset equals label name right there. So we're only applying this one to the label. So if any record has the label missing, we're going to drop the entire record. In place equals true. So now in this case, it should keep, there we go. It gets rid of any row missing name, but kept those 144 rows that were missing host name because it's not the label. All right, I just wanted you to see how that was going to work. So I'm going to add average review back in as our label, not that we need it. In fact, I'll just get rid of it. Okay. Next, it gets a little bit more complicated. So what I want to do now is I want to compare, in order for this to work, I want to go through each column one at a time. So we're going to need a loop. And I want to check and see how many values will be remaining in the whole data frame if we were to drop the column versus drop the rows that are missing data in that column, and see what I have left. And I want to keep the one that's higher between the two of those things. All right, so this is going to get a little complicated, but stay with me. It's not too bad. So I'm going to say, let's create a df results output data frame, pd.dataframe, columns equals, let's have number missing, and this will be the amount left if we drop the column and the amount left after we drop rows. And then for feat in df, let's go through each feature one at a time. Now, remember, at this point, we've already dropped any rows past the threshold, columns past the threshold, and anything missing in the label. So we're still having to take care of everything that's left. This was just a chance to get rid of low-hanging fruit up here, the stuff that clearly need to be dropped. So now we're going to go through everything else one at a time and decide whether it's better to drop the row or the column. All right, so missing, let's calculate this as df feet dot isNA.sum. And then if missing is greater than 0, so we're only going to do this if it's actually missing data, then let's calculate the memory left if we drop the call as df.drop columns feet, and then we're going to count what's left. So we drop the columns equals feet. We drop the feature that we're on, and then what's left will be in here. Notice I'm not doing this in place equals true, because I don't want to actually drop it yet. I just want to get the number that are missing, that will be left if we were to drop it, and store it in memory call. And then let's see what's left after dropping rows. So drop, but this one's going to have to be drop NA, and instead of columns, we refer to this as subset for the drop NA function. There we go. So values left if we drop the column, values left if we drop the rows. I'm going to go ahead and stick this in that data frame that we created above. dsResults.loc feet equals, let's plug in the missing data, memory calls, memory rows. And I'm doing this because I want to sort this table, memory call, and find which combination, which column should be dropped, or whether we should drop the memory, it's going to go through and generate this. Let's just print it out rather than me try to explain it for you. That'll be a lot easier. So rather than return df, I'm going to return df results just for a moment so you can see what this is going to do. Oh, I got to spell it right. All right, so here's what we got. There was only two columns left, or two columns with missing values left. And if we were to drop the name column, we'd have 246,000 left. And if we were to drop just the rows missing those values, we get 263 left. So now that we've generated this, I want to start by dropping where I have the highest amount left. I want to look at all of these values right here. And in this case, it just happens to be that name is first. So I'm starting with, it's usually going to start with the one that has the fewest rows with missing data. And I'm going to start by dropping rows for name, because that will leave me with the most data remaining. Then I'm going to generate the table again after I've done that, and then drop the highest one of the next two. So for a moment, I'm going to take this out actually, just so you can see this with all the missing data. Okay, we actually get all of these. So neighborhood group, that one has every row missing. If I were to drop NA on that one, I'll have nothing left. But if I drop the column, I'll actually have the same amount left that I started with. So what I'm getting at is for this dropping algorithm to work, I want to now sort by getting the max value in either one of these at the top, and then find the name of that column and drop that based on that column name, whether it's the columns that are highest or the rows that are highest. So for example, I've got this. I'm going to turn this into a function that can be called. I want to generate this table, so I'm going to change this to a function inside of a function and call this def generate missing table. And this is going to return df results. Then I'm going to come down here, call that, and use it, but name it correctly. Generate. Let me go back to df on this one. Okay, so I'm going to create my results by calling generate missing table. Then while df results 0 is greater than 0. So oops, sorry, not 0. Dot shape greater than 0. So dot shape 0 returns the number of rows, meaning there's still rows left in this table that have missing data. Because notice it only puts a row in this table if there's missing data. So that's why we're only seeing these 4 columns, even though there's a bunch of columns down here. So each time through this loop down here, I want to find the row name and the column name of the largest count of data left so that I'm keeping as much as possible. Okay, so right here, I want to find the max value across all of these 2 columns right here. So to get that, I'm going to say max equals df results and just grab columns and rows. I don't need the missing values table. I just leave that in here because it's mildly useful and interesting. So df results, just look at those 2 columns only and say dot max and pass in axis equals 1. Sorry, lowercase axis equals 1. And give us the first value that it returns. So let me show you. Print max. Oh, I better not run this because that's going to give me an infinite loop. What I need to do is before I run this, remove the row, drop the data, and remove the row that has the most, that will retain the most. So I'm going to, next I need to know which axis is this max coming from the column or the rows, so I know which one to drop. So I'm going to make one called max axis equals df results dot columns, pass in df results dot is in, pass in that max value I just created. So this is saying grab a list of the columns from df results and find which columns, which has the max in dot any of the rows and give me the first one that's returned. Okay, I know that's kind of complicated, but let me show you what you get. It took me a while to debug this. Max axis. Well, I'm not going to print it out yet because I still need to remove this thing. So what I want to do next is sort df results by whether it's columns or rows with the highest value on top. So df results.sort values by equals rows or columns. We get that from max axis. And then ascending is going to equal false. So we get it highest to lowest. And in place equals true so that it's permanently sorted. Then I want to print that out. If messages, print a new line break to separate them and print out that table below, df results, so you can see it each time. Then if max axis equals rows, then we're going to drop NA. df dot drop NA. Notice I'm doing this from the original data frame, not from df results. We're going to regenerate df results each time through this loop. We did it once at the beginning, but I'm going to do it here at the end as well. So df dot drop NA, axis equals 0 for rows. Subset is going to be basically only on the name of the feature that I'm on. So the feature that's at the top that has the highest count of remaining values on columns or rows. So it's going to be df results dot index of the very first row. So that'll return the index name of this column. So drop only based on that column. In place equals true. All right, otherwise, if max axis is columns, then df dot, you can do drop or drop na equals either one. I'll just do columns equals, same thing, df results dot index, the very first one on the list, which is going to be the highest one, and in place equals true. At the end, now that it's been dropped, I'm going to reset df results equal to generate missing table again. So this table will get regenerated, but that one at the top of the list is going to be missing now because we either dropped its rows or we dropped its column, depending on which one leaves the most remaining. All right, let's run that. Oh, columns not in index, because I called it column with no S. Okay, notice what happens here. I should add .head onto the end of this. So first time through, just like we had before, name had only 34 rows missing. And so if we dropped the rows, it would save more data overall than if we dropped the column, the whole column name. And so by sorting by the max value in rows, that puts name at the top. We drop all the rows missing. It went right here, dropped the rows that were missing name. And then the next time through, when we called df results, it generated this table again, resorted it by host name next, and it looks like it's better to drop the rows than to drop the columns. This keeps more data. So it just went through and did the same thing each time. Drop that one. Technically, neighborhood group. Oh, this should have been the same, because that's technically the max value. Let me check my logic real quick. But notice we get there eventually anyway to the same place. It just didn't do it until this last time right here. I don't know why it... I'll check my code here in a bit. We get to the end, it finally drops this. Let's just print out a message when all is done, so we can see kind of overall what we ended up with. And also, I want to verify isNA.sum, verify there's truly nothing left. But right here, I'm going to print out a message. Just kind of a summary of what happened. I'm going to round, first of all, df.count.sum divided by start count. This is giving me a percent of values that are going to be dropped. Let's see, I'll times that by 100 and round to 2 digits, add a percent sign. So this is the percent of data that was kept at the end. So that, and then I'll put in a df.count.sum right here. Let's see, I'll need that. I'm just going to tell them exactly what was left. Start count. So that percent of non-null cells were kept. All right, let's run this thing now. Oh, let's see. What did I miss here? Float. Oh, it returns a df. No, that's right. Percent for float instead of, oh, did I put the percent in the wrong place? Oh, I forgot my closing curly brace right there. Oh, I'm missing something else here. What am I missing? A single. Oh, this doesn't go right here. That's where I had it in the wrong spot. Let's see if that did it. All right, so first time through the loop, we kept 99.85% of the values after dropping name. You know, I should probably put this print NA. No, that's fine. We're kept. I could say after dropping I'll put, whether it's rows or columns, this is max axis from feet. Oh, is feet not defined right there? Let's see. The column, oh, it's this right here. This gets us the index name. That's what I wanted. Okay. Perfect. Oh, and I got one more thing to take a look at. But let's start with this one. So 99.85% were kept after dropping rows from host name. Oh, but name. Why is it not printing that one out? If messages. No, this is the total. This is meant to go outside of this loop. Sorry as I sit here and debug my own code along with you. I'm just going to get rid of all this right here. I just want this to be an overall. There we go. Perfect. Okay. So by the time we got to the end, we kept 87.29% of the whole data set. This many rows out of, or this many values out of that many originally, and as a sanity check, no missing data left. So this function went through and just took care of dropping data for us, if that's the route we wanted to go. So I would run this function after we've checked for any possible way to replace with a theoretical value. And we've also determined that we don't want to impute a value. This wants to drop everything, but we can modify, actually we'll modify this function in the next video to decide whether we want to impute after we go through and well, actually let's put these back in. So we go through and make an initial drop of low-hanging fruit. Any row that's missing more than 90%, any column missing more than 50%. And in the next video, we'll modify this function further to then decide with the remaining missing data, do we want to drop it or impute it? And so we'll stop here for now because this function is still very useful as it is. Yeah, let's run it one last time now that we've got all this done. Okay, down here, we started with that many rows. After taking care of the low-hanging fruit, there's only 2 left with missing values. Those 2, it got rid of name first, and of that, we ended up with 87.63%. Not bad, still pretty good. Okay, we'll stop it here.